Bismillahirrahmanirrahim. Assalamu alaikum. Lecture number 1, unit number 2. The title of the unit number 2 is Matrices in Determinant. So in the first part of this chapter we will discuss about the matrices, and then we will discuss how we can take the determinant of a matrices. So first we will briefly discuss matrices. In this video lecture, the topic of this video lecture is introduction and applications of matrices. You know that from the previous classes that the knowledge of matrices is necessary in various branches of mathematics. Matrices are one of the most powerful tools in mathematics. This is a very powerful tool. This mathematical tool simplify our work to great extent as compared to the straightforward methods. So how you can justify this point that matrices is simplifies our work to great extent as compared to straightforward methods, straightforward procedures that we used in mathematics. So remember, it means alternatively it means that the matrices have the ability to simplify mathematics. So how matrices simplify mathematics, and after that we will discuss the uses in technology. For example, if I consider a linear system, a system of linear equations, let's say the system of linear equation is 7x plus 4y equal to 1. This is the first linear equation in two variables, and let's say another linear equation in two variables is 3x minus 7y equal to 13. So this is a system of linear equations. This is a system of linear equations. If you want to solve this system, you need to find out the value of x and y which satisfies both these equations. So that values are called the solution of this system. So there are different methods. We have the equating coefficient method, elimination by substitution, cross multiplication. These are the methods, but these methods are not too simple. When the system contains the equations having more than 2 or 3 or 4 or 5 variables, so that becomes so difficult to solve that systems. So alternatively, if we convert that system into matrices, so if we convert that system into matrices, so then we can easily solve this system and we can easily find the solution. You know from the previous classes that this system is converted into matrices as first we write a matrix which is called a coefficient matrix, consists of the coefficients of the variables. So 7 is the coefficient of x, 4 is the coefficient of y of the equation number 1. So this is written in the first row. Then 3 and minus 7 are the coefficients of the x and y in the second equation. So that is written in the second row. So this is called the coefficient matrix. This is a square matrix. We will discuss that in detail. And this is xy, and which is equal to 1 and 3. So this is the column vector or column matrix of unknowns, and this is a column vector or column matrix of constants. So you see that the given system is converted into matrices, and then we can easily solve these, and we can easily convert these matrices to find out the value of x and y. So this is one of the beauty of matrices, that it helps us to simplify mathematics. So this is one of the reason that we study matrices. So it helps us to simplify mathematics. And the second is uses of technology. Before to discuss the uses in technology, we briefly discussed that you see that The knowledge of matrices are necessary in various branches of mathematics. Matrices are one of the most powerful tools in mathematics. These mathematical tools simplify our work to great extent as compared to the straightforward methods. The evolutions of the concept of matrices. This is the important point. The evolution of the concept of the matrices is the result of an attempt to obtain the compact and simple method for solving the system of linear equations, which I already explained here. So this is one of the reasons for studying the matrices. Now, what are the applications of matrices in technology? Remember, what are the uses of them? If all the electronic images, let's say we have an image in a computer or an image in mobile or an image on any other electronic devices. So images actually made from pixels. Remember, you all know that images are actually made from pixels, and behind each pixel or behind the pixels we have matrices. So actually images are matrices. I'm repeating this point again. For every image, it may be in computer, it may be in mobile, it may be in any other electronic device, images are made from pixels, and behind the image we have pixel, you can say, and behind the pixels we have matrices. So actually images are made from matrices. So this is one of the uses of matrices. If you want to study some images, satellite images, medical images, you need to convert that into the matrices, and then you can study that. Remember, we have a software which is called MATLAB. This mat is taken from matrix and lab is from laboratory. So matrix laboratory, this is a software, this is a mathematical software with the help of which we convert every image into matrices and matrices into images. So this is one of the uses of matrices in technology. So I am sharing the laptop screen with you to show that how you can see how you can convert the images into matrices. You see that here, you clearly see that this is an image of some person. When it zoomed, so you see that it converted into square blocks. So actually behind these square blocks are actually pixels, assessing pixel values using MATLAB. So when you assess the values behind the pixels, so that actually made a matrix, So you see that when it zoom, the factor is zoomed, so it you see the pixels, and behind each pixel we have matrices. And this is a software which is known as MATLAB. With the help of MATLAB, you can convert the images into matrices. So this is one of the important tool that we uses, one of the important software that we uses to convert the images into matrices, and then we study those images. So this is one of the most important applications of matrices. So you see, the electronic images are made from pixels. For each pixel value there must be a matrix. Thus an image can be represented as a matrix of Fraxel values. Mean behind every image we have some matrices. Therefore, nowadays matrices and matrix methods have widespread applications in the operations of high-speed computers. For each image there is a matrix, and for each matrix we have an image. So remember, each image can be converted into matrices, and each matrix has been converted into their image. MATLAB, taken from matrix, lab mean laboratory, is a high performance interactive software for the scientist and engineer to convert images to their Fraxel matrices. So these are the applications and applications of the matrices. So this is about the motivation of the matrices, that why we are studying matrices. Inshallah, in upcoming videos we will discuss the concept of a matrix, and then we will proceed to study the matrices. But remember, if you see to the this, I'm sharing again the left of screen. You see that when you zoom it, the picture is actually, the image is actually converted into square blocks. So actually behind the image we have a square matrices. So that's why you will see that we will mostly discuss about the square matrices, and most of the theoretical and conceptual work is on the square matrices, because that square matrices are used in the applications. We have rectangular matrices and so many other matrices, but that matrices are not used in the applications. The square matrices are used in the application, and this is the reason. When you zoom a factor, so behind the Fraxels, when you get a Fraxels of the image, behind the Fraxels we have square matrices. So remember, this is the importance of the square matrix. So that's why most of the work in this chapter will be on the square matrices. We will we will find out the determinant of the square matrices only. We will find out the inverse of the square matrices. We will take the we will find the rank of a square matrix. We will find the convert a square matrix into echelon and the reduced echelon form. So all the conceptual work in detail is on the square matrices. The rectangular matrices and other matrices will be just discussed their definitions. We will discuss just their definition, and most of the work is on the square matrices. So this is the reason that why we study square matrices in detail, because in applications we have square matrices. Thank you.